Welcome to the St. Joseph College for Women Autonomous Visakhapatnam. Department of Mathematics. Welcome you for the online course on real analysis. In this module, we discuss about the infinite series. Myself, G. Yojna, Assistant Professor, Department of Mathematics, St. Joseph College for Women, Visakhapatnam. Course outcomes. After successfully completion of this lesson, the students will be able to understand the concept of infinite series and distinguish between convergent and divergent series. Apply various convergence tests such as the comparison test, ratio test, root test, integral test and alternating series test. Analyze and classify series including geometric series, piece series and alternating series. Approximate values and functions using partial sums of convergent series. Develop mathematical reasoning and proof techniques related to infinite series and series. Course objectives. First one, understand sequence and series. Learn the basic of sequence and infinite series. Explore convergence and divergence. Identify when a series adds up to infinite value or not. Learn convergence test. Use different methods to check if a series convergent. Study special series. Work with important series like geometric, harmonic and power series. Apply infinite series. Use series in real-world problems like physics, engineering and computing. Content. In this module, we discuss about definitions, theorems related problems, conclusion and finally practice problems. Now coming to the definition. Infinite series. If un be a sequence of real number, the expression u1 plus u2 plus u3 plus so on un is called infinite series and it is denoted by sigma n equal to 1 to infinity un or sigma un. The numbers u1, u2, u3 so on un are called as first, second and nth term of the series. Next note. Infinite series is a sequence of special kind. Second one, sometimes the series beginning with n equal to 0 instead of n equal to 1. Now next one, partial sum. If sigma un be a series, then Sn is equal to u1 plus u2 plus u3 plus so on un is called the n partial sum of sigma un. Next one, convergent series. The series sigma un convergence if the sequence Sn of its partial sum convergence. Divergent series. The series sigma un divergence if the sequence Sn of its partial sum divergence. Now coming to the first theorem. A necessary condition for convergence or nth term test. What is the statement? If sigma un convergence, then limit un equal to 0. Going to the proof, given that sigma un convergence, now we have to prove that limit un equal to 0. For that, let sigma un convergence to S, Sn be the nth partial sum of sigma un and let Sn equal to limit Sn equal to S. Now Sn is equal to u1 plus u2 plus u3 plus so on u of n minus 1 plus un. Sn is equal to from u1, u2, u3 so on u of n minus 1 can be written as s of n minus 1 plus un. That implies un can be written as Sn minus s of n minus 1. And both sides we should apply limit. Then limit un equal to limit of Sn minus s of n minus 1. That implies limit Sn minus limit s of n minus 1. Already we know that limit Sn equal to s and also limit s of n minus 1 is also s. Therefore, instead of limit s of n minus 1 we should write on s minus s equal to 0. Therefore, limit un equal to 0. Note, the convergence of the above theorem is not true. That is, limit un equal to 0, then sigma un is not convergent. Example, sigma 1 by n. Quachi's criterion for series. Statement. A series sigma un convergence if and only if for all epsilon greater than 0 there exists m belongs to z plus such that mod u of p plus 1 plus u of p plus 2 plus u of p plus 3 plus so on plus u of q that is less than epsilon for all q greater than or equal to p greater than or equal to m. Now proof. Given that sigma un convergence. So convergence, first we can take, let Sn be the nth partial sum of sigma un. Therefore, Sn equal to un plus u2 plus u3 plus so on un. Based on that, we can take S of p is equal to u1 plus u2 plus u3 plus so on up to up. Similarly, we should add on the Sq, that is equal to u1 plus u2 plus u3 plus so on up plus u of p plus 1 u of p plus 2 plus so on u of pq. Why? Because here q greater than or equal to p. So based on that we should write down. Now we can doing sp is subtracted from the sq. Finally we will get u of p plus 1 plus u of p plus 2 plus so on u of pq. So now sigma un is convergent. So series is convergent if and only sequence is always also convergent. So by the Quachi's general principle of convergence of a sequence Sn convergent, sequence convergent if and only if sequence is a Quachi sequence. By the definition of Quachi sequence, if and only if for all epsilon greater than 0 there exists m belongs to z plus such that mod sq minus sp less than epsilon for all q greater than or equal to p greater than or equal to m. If and only if for all epsilon greater than 0 there exists m belongs to z plus such that right now we should calculate the sq minus sp. What is that value? Modulus of u of p plus 1 plus u of p plus 2 plus u of p plus 3 plus so on u of u of q. That value, what is that? Less than q. For all q greater than or equal to p greater than or equal to m. That is only we have to show that. Hence the theorem is proved. Next theorem is geometric series. Prove that sigma n equal to 0 to infinity r power of n convergence to 1 by 1 minus r if mod r less than 1 and sigma n equal to 0 to infinity r power of n divergence if mod r greater than or equal to 1. Proof. Let sigma un is equal to sigma. What is the un value? R power of n. So where un is equal to r power of n. So let Sn be the nth partial sum of sigma un. So based on that, first we can take Sn, n partial sum. Sn equal to u0 plus u1 plus u2 plus u3 plus so on un. What is the un value? R power of n. So u0 is nothing but r power of 0. u1 is nothing but r power of n. u2 is nothing but r square. So that is equal to r power of 0 plus r power of 1 plus r square plus so on r power of n. Now case 1. What is our case 1? If mod r less than 1, it can be written as minus 1 less than r less than 1. So now do you know S of Sn, that is equal to 1 plus r square plus so on r power of n minus 1 plus r power of r. So both sides multiplying with r, now we can get r into Sn is equal to r plus r square plus r cube plus so on r power of n plus r power of n plus 1. Again on both sides adding 1 on both sides. So 1 plus r into Sn is equal to 1 plus r square plus r cube plus so on r power of n plus r power of n plus 1. That implies 1 plus r into Sn is equal to, do you know value? 1 plus r square plus r cube plus so on r power of n value, what is that? Sn. So instead of we should write an Sn plus r power of n plus 1. Next one, r power of n plus 1 we can send to the left side. 1 minus r power of n plus 1 is equal to Sn minus r into Sn. That implies 1 minus r power of n plus 1 is equal to, taking Sn common, 1 minus r. So based on that we should find the Sn. Sn is equal to 1 minus r power of n plus 1 by 1 minus r. That is equal to, in the numerator 2 parts, that is separated with the denominator, it can be written as 1 by 1 minus r minus r power of n plus 1 by 1 minus r. That implies Sn is Sn minus 1 by 1 minus r is equal to minus r power of n plus 1 by 1 minus r. That implies mod Sn minus 1 by 1 minus r is less than or equal to mod r whole power of n plus 1 by 1 minus r. We know that mod of r power of n converges to 0 when if mod r less than 1. Therefore, limit mod r power of n equal to 0. So by the sandwich theorem, mod r power of n value 0. By the sandwich theorem, limit Sn minus 1 by 1 minus r equal to 0. That implies limit Sn is equal to 1 by 1 minus r. Therefore, sigma un converges to 1 by 1 minus r. Which case if mod r less than 1. Case 2. If mod r greater than or equal to 1. That is r less than or equal to minus 1 or r greater than or equal to 1. Therefore, r power of n does not approach to 0. Either r less than or equal to minus 1 or r greater than or equal to 1. By the nth term test, so here limit does not exist. Limit does not exist means, so therefore sigma un is divergent. Next note, if 0 less than or equal to r less than 1, then sigma r power of n equal to 1 by 1 minus r. This is the note point. And next one, auxiliary series or P series test. What is the statement? The series sigma 1 by n power of p can be written as 1 by 1 power of p plus 1 by 2 power of p plus 1 by 3 power of p plus so on, where p belongs to r. Then convergence if p greater than 1, divergence if 0 less than p less than or equal to 1, and also it is divergent if p less than or equal to 0. This is the statement of the auxiliary series or P series test. Thank you.